All right, let's go through this extension. This is something that we used to do in the past, but due to time restraints this year, we did not actually teach this lesson. But what this lesson is combines what you just did in the previous chapter, which is solving equations with square roots, and then also combining concepts from a couple of chapters ago when we were factoring. So let's take a look at this first example here. So follow along. We're going to do the first two problems together on the paper, and then I'm going to have you try the last four problems by yourself. So this first equation says we've got the square root of negative 36 plus 12n, and that equals n. So remember, when you have an equation where you have one square root, you want to make sure that that square root is isolated by itself. Because everything, as far as those numbers and variables go, are under the square root, that is already considered isolated by itself. So then your next thought is, how do I get rid of that square root? What I want to do is I want to square both sides. So I'm going to take the square root of negative 36 plus 12n, and I'm going to square it. But what I do to the left side, I have to do it to the right side. So the n is also getting squared. Now, when you square a square root, it's going to get rid of that radical, and it leaves you with what was underneath. So that is a negative 36 plus 12n. On the other side, n squared stays n squared. You just don't need the parentheses anymore. Now, if you remember back to a couple of chapters ago, when you have an n, or like an x squared, an x in a number, or in this case, it's an n squared and n in a number, we want to think about factoring. We've got three different terms. So if you remember, like ax squared plus bx plus c equals 0, that's what we need in order to factor. So right now, I don't see it equaling 0. I do want that n squared term to be positive. I never want that to be negative. So that means I want to move the terms from the left over to the right to make it say equal 0. That means that that negative 36 needs to get added to the other side, and that positive 12n needs to be subtracted. So when I do that, it gets rid of the two terms on the left, and it makes it say 0. That's going to equal, none of these terms on the right are like terms, so I'm going to put it in what we call standard form. N squared minus 12n plus 36. Okay, this is the form that we want to factor. So remember, when you're factoring, because there is technically a 1 in front of the n squared, if you're looking for a GCF, they are not going to have any numbers in common. Because that 36 doesn't have any variables, I'm not going to have a GCF. So there is no GCF. So then your thought process is asking yourself, what is going to multiply to the last number, but add to the number in the middle? So if you remember, we can make a little chart. What multiplies to 36, but is going to add to negative 12? Well, if it needs to multiply to a positive, but add to a negative, we want to be thinking about two negative numbers. Negative 6 times negative 6 is going to give me positive 36 when we multiply. But when I add these two things, notice how we get that negative 12 in the middle. So we'll still have that 0 equals, but then the whole point in factoring is that it creates these two parentheses. Because my term is n squared, I'm going to start each parenthesis with an n, and I'm going to end it with a negative 6. So now because it equals 0, I need to take each parenthesis, set it equal to 0, and solve for n. In this case, because you have the exact same parenthesis, I'm going to, take just n minus 6. I'm just going to do it one time. I'm going to set it equal to 0, and I'm going to solve. So to get that n by itself, we're going to have to add the 6. And so that's why our potential answer is n equals 6. Now, if we had two different numbers in those parentheses, I would then want to set each parenthesis equal to 0 and then solve for that variable. But remember, the whole point is that I have to check for extraneous solutions because these answers might not necessarily be the correct answer. So remember, that means I go back up to wherever I see an n, and I'm going to substitute in the number that we think it is, and we're going to determine if the left side really equals the right side. So let's check. If you had more than one different number for a variable, you would have to check that multiple times. So here we just have one number, we just have to check 6. So that means that under the square root, we will have negative 36 plus, and then it's 12 times n. So we're going to substitute 6 in. That's going to equal, then I want to take then 6. So now I want to see, does the left side really equal the right side? I would simplify what we have underneath the square root. So if you multiply that 12 and that 6 together, it's going to give you 72. So under the square root, we have negative 36 plus 72. If I add those two numbers together, it's going to give me, so I'm running out of room, so I'm going to write it over here. We'll get 36 under the square root. And remember, I want to know, does that equal 6? So if you then take the square root of 36, you will get 6. So the nice thing about this is that the only number that we think it might be, it actually is, because we got the left side to equal the right side. So that means I can circle that answer. 6 for n is my final answer. So let's take a look at the second example. If we have m equals the square root of 2m. Once again, when I see only one radical, I want to make sure that that is completely by itself. And in this case, because the 2 is underneath the radical, it is. There's no numbers outside of that square root. So that means that I want to start by getting rid of that square root. And that means I am going to square both sides. Because remember, to undo a square root, we square. So if I square m, it's just going to keep it as m squared. When I square the square root of 2m, it's just going to turn into 2m. Because there is an m squared and an m, I want to do what we just did in the last problem over here. I want it to be equal to 0. I want to keep the squared term positive, so I want to move the 2m over by subtracting. Now, that gets rid of that 2m and it gives it to me to equal 0. M squared and negative 2m are not like terms, so I have to keep them separate. Now, because I don't have 3 terms, I'm not going to be able to factor it like we did in the first problem. But remember, the very first thing that we should be thinking about, and we did it in the other problem, is I looked to see if I have a GCF. So if you notice that there's a 1 in front of the m squared, I'm not going to have a number in common because anytime I have a 1, there's nothing bigger than a 1. And taking out a 1 doesn't change any numbers. But if I look at both of these terms, they both have variables. Notice that m squared is the same thing as m times m. So notice that it has an m in common with both of those terms. So I can factor out an m, which means that I have to go back and put whatever is left over back in parentheses. So m squared was m times m. If one m got moved out, I still have 1 left over. We'll bring down that negative sign. 2m, I took out the m, I'm left with the 2. So now wherever I see a variable, I have to set that equal to 0. Technically, this GCF on the outside, because it's a variable, I'm going to take that and I'm going to set it equal to 0. The only thing is that we don't have to do anything to solve. It already is solved for. So there's my first answer. But then I have to take what's in parentheses and set that equal to 0 as well. So how am I going to solve for m in the second equation? Well, I'm going to add 2 to both sides. That gets rid of the 2 on the left, and 0 plus 2 is 2. So notice that I have 2 potential answers here. I have to check both of them to see if I have a true statement. If they are both true, well, then both of them are my answers. Maybe only one of them is true, so then only one would be my answer. Maybe they both aren't true, and then I wouldn't have any answers at all. But I have to go back and check. So I'm going to check m equals 0 first. So to do that, notice that there are 2 different places for me to substitute in my 0. So I want to know, does 0 equal the square root of 2 times 0? Well, it can't do anything to change the left side, but notice that under the square root, if I multiply 2 times 0, I'm going to get 0. So the question is, what is the square root of 0? And if you put it into the calculator, you'll see that it does equal 0. So that means I can circle m equals 0. That is a solution. But because there are two potential answers, I'm going to check the other one. So I'm also going to check, does m really equal 2? So once again, I'm going to have to plug 2 into both of those m's in my original equation. So 2 equals, I want to know, does that really equal the square root of 2 times 2? So underneath the square root, 2 times 2 is 4. If I put the square root of 4 in the calculator, this one works out as well. We get that to equal 2, so that means I can circle this one as well. We do have two answers here. So like I said, hopefully you followed along and you filled that out. And so now you've got several more problems on that worksheet. I want you to try them by yourself.